Good afternoon, everyone. I'm Bodi from Berkeley, and I'm going to talk about our proposed method, Iterative Cross Learning (ICL), which is a machine learning method trained to train the model on noisy data set. So first, let's take a look at this survey. So survey from Kaggle. It shows the biggest concern of the data science is the data itself. So the data is always dirty in practice. And it has been so sad that 80% data science is cleaning the data, and the other 20% is complaining about cleaning the data. And as you all know, these two commonly used data sets. They are perfect, they are 100% clean. But in practice, the data is more likely to be like this. The labels are not always correct. So we propose our method, ICL. We use two different networks, two independent networks to train on the different subset of the original noisy data set. And after training, we ask the two classifiers to predict labels for the original noisy data set and update the original labels. Then we make the original label less and less noise. We call that one stage. And we have several stages, so that's why we call it iterative method. So the way we update the labels is we ask two classifiers to predict labels for every data point. If they get agreement, we will trust their prediction. If they disagree with each other, we will update the label with a random label. So that's a key point of our method. So it's like two students cheating in an exam. If they find they get the same answer on one question, they feel they get a correct answer. And if they get a different answer on a question, they cannot trust any of them. So here's a visualization of the configuration matrix. So the configuration matrix represents the distribution of the noise, and here the darker, the less noisy. And at the first, it's a noisy data set. And as you can see, with using our method after each stage, we get less and less noisy data set. So here's a part of our results. So first, we test on three different noise levels, 30%, 50%, and 70%. And the vertical axis is the error rate. The lower, the better. The blue bars are the result from the underlying model, and the orange bars are the result combined with our method. So on the left is our method combined with a base CNN, which means a pretty simple CNN. And as you can see, we reduce the error rate a lot. And on the right is the result we combined with a model proposed in 2016. And we also reduce the error rate a lot. And in conclusion, as you can see, our method is pretty easy. It's easy to implement. And the good advantage of our method is there's no hyperparameters you need to turn. So you don't have to spend a lot of time turning hyperparameters. And the most important thing is we improve the performance a lot. And we have an overall improvement on any underlying model combined with our method. And we also achieve a state-of-the-art performance on noisy labels problems. And the last thing, the best thing is that it can easily combine with our method. So as long as you have a model which can address noise, you can try our method and combine with our method. And that's it. And hope you can come to our post session. Thanks very much.